So children, here today we are going to study about the modulus of elasticity. So first of all we should try to understand that what is the meaning of modulus of elasticity. A modulus of elasticity is a ratio of, so it is the ratio and the ratio of stress and strain. It is a ratio of stress and strain, whereas the stress are restoring forces per unit area developed in the material due to the strain, and the strain is the change in the dimension per unit dimension of the material. So now the types. The types of modulus of elasticity are, the very first is Young's modulus. The Young's modulus means it is the ratio of longitudinal stress to the longitudinal strain. What is the meaning of longitudinal stress? The stress which is applied longitudinally. Longitudinally means, now here is a diagram. It is a wire hanging from the roof. Its area of cross section is A, its length is L. Now the load is applied longitudinally, so its length is being elongated. So this is the longitudinal stress, or also called as tensile stress. Then longitudinal strain. The meaning of longitudinal strain is the strain which is produced along the length. So let us take this example of the wire of length L and of cross-sectional area A. Now when the load is applied, it undergoes a change in the length, that is delta L. This wire undergoes a change in the length, is delta L. Now in this case the longitudinal stress is F by A. This is the stress, restoring forces developed per unit area. So the longitudinal stress is F by A and the longitudinal strain is delta L by L. Change in dimension is delta L and the original dimension is L. So the Young's modulus is F by A upon delta L by L, or we can write this as F into L upon A into delta L from this. The another way to solve it, by putting the value, that the value of F is mg. M is the mass, the total mass hanging from this wire, and the area of cross section in the terms of radius is pi r square. So if we put this, then we get Y Young's modulus is equal to mg. Mg is the force, L is the length, pi r square, this is the cross sectional area, into delta L. And this formula is very useful in numericals.